Hello students. I hope that you're okay. So now we're going to move to the second last part of calculus, which is the graphical application, specifically on cubic functions. Okay. So first of all, this is what we need to discuss. We can remember from functions that we have different types of functions. Okay. Now I want us to understand how is a cubic function related to other functions. Okay, first of all, from given an equation, how can you tell that you have a cubic function? Okay, let me tell you something. Okay, if you got an equation like this, right, and then you got an equation like this, and then an equation like this, and then an equation like this, and then an equation like this. An equation like this. Can you name all of these functions? I give you a bit of a minute for that. Can you pause the video and try to name all these functions, okay? Alright, so this is how you can name them. You have to check the highest exponent on x. What is the highest exponent here on x? The highest exponent is 1, isn't it? So if the highest exponent is 1, then it tells you that this is a straight line graph. Okay, so this would be a straight line graph or a straight line function. It looks like that. Okay, or it can be like this. That is your simple straight line graph. What about this one? The highest exponent is what? Is 2. If you have a situation like that, then that is a quadratic function. Okay, that is a quadratic function, or also called a parabola, right? And then it looks like this and like that. Okay, now what about this one here? What is the highest exponent? Is 3, right? So if you have the highest exponent is 3, that is your cubic function. Okay, that is a cubic function, and then it looks like this or like this. All right, and then here the x is a denominator, right? You can say here the exponent is -1. So if your exponent is -1, it means you are dealing with a hyperbola. Okay, you're dealing with a hyperbola, which is like this, right? It's like this, or it can be like this, right? It can be like this. And then here, if the x is the exponent is x, then you should know that we are dealing with an exponential. Okay, we're talking about an exponential, and it can look like this, right? Sorry, let me try it again. It can look like this, or it can look like this. Okay, so that is how you determine what type of function you are dealing with, just using the exponent on x. Alright, so I need you to know that why do I have them in two versions? All of these versions here are determined by the value of a. Okay, by the value of a. For example, here if a is positive, this is the graph that you will get. Here if a is negative, this is the graph you will get. Here if a is positive, this is the graph you will get. Here if a is negative, this is the graph you will get. Here if a is positive, this is the graph you will get. Here if a is negative, you get this one. Here it's when a is positive, and then here is when a is negative. Here it's a bit of a different story here. Okay, story for another day. So you can see that a has a very powerful influence on the shape of the graph. It has a powerful influence on the shape of the graph. Okay, on the shape of the graph. So our main focus is here, isn't it? This is our main focus there. a cubic function in grade 12. So now that we know what is a cubic function, let's properly define it now. Okay, so a cubic function is a function that has the general formula, right? The general formula or the standard formula, which is y is equal to ax cubed plus bx squared plus cx plus d. Remember, the general formula of a parabola is ax squared plus bx plus c. The general formula of a cubic function, right? So this is for a what? This is for a cubic function. The general formula is y is equal to ax cubed plus bx squared plus cx plus d. As you can see, the highest exponent is 3. And this is your a there. Okay? So, I need you to know that from this formula here, d is called the y-intercept. Okay? From that formula there, d is called the y-intercept. Right? So, and this is your a here. Now, you should know that if your a is positive, meaning greater than 0, okay, if your a is positive, the graph is going to start by increasing, then it's going to decrease, and then it's going to increase again. How do we know a graph is increasing? Remember, we use our vertical line test, isn't it? Our vertical line test. And yes, so remember, you move from left to right, you will see that on this part here, the graph would be increasing. And then on this part here, the graph would be decreasing. So at this point here, whereby the graph changes from increasing to decreasing, this point here, we call it a turning point, okay? We call it a turning point. Here, if we can check, I'm going to color it with yellow. From here, the graph is decreasing, isn't it? In fact, let's try red. Here, the graph is decreasing here. What about here? Here, the graph is increasing. On that blue part there, the graph is increasing again, right? So here, whereby it changes from increasing to decreasing, that point there, we call it a turning point. Okay, we call it a turning point. So this is a cubic function there. Now this turning point is actually called local maximum. Okay, local maximum, while this turning point here is called local minimum. Okay, it's called local minimum. Why is it called local maximum, this one, and why this one is called local minimum? It's because if you can check this graph, it keeps on increasing until infinity. So the maximum number is actually unknown. So the one that we know locally, that is the highest point, would be this point here. We know it as the highest point locally, while this one we know it as the lowest point locally. So that's why it's called local minima, because there is a real minimum here that we do not know. It's about at negative infinity. So this one is the one that we know locally. This one is the one that we know locally. All right. And all of this is when a is greater than 0. But when a is less than 0, right? If a is less than 0, meaning that it's negative. An example of a function like that would have y is equals to negative maybe 2x cubed plus 6x plus 8. Something like that. As long as a is negative, that graph would be shaped in this way. That graph would be looking like this. It's gonna start by decreasing, then it's gonna increase, and then it's gonna decrease again. Okay, so the shape will be looking like this. So remember, this is your local maximum, right? It's a local maximum. What about this one? It's your local minimum. And remember, these 2 points are called your turning points. Okay, those are called turning points. Another name for turning point is actually that we would be using often is called stationary points. Okay, so it's a stationary point. So this here is called a local maximum, or you can say it's a stationary point, right? It's a stationary point, and then even this one is a stationary point. So the question will just be, amongst your stationary points, which one is the maximum and which one is the minimum? Okay, so stationary point is another name for turning point. Okay, that is another name for turning point. Now, so here the graph is decreasing, as you can see from this yellow part here. This part here, the graph would be decreasing. Okay, same as on this yellow part here. Okay, the graph would be decreasing. Okay, but here the graph would be increasing on this part here. Okay, so here the graph would be increasing there, right? So it decrease first and then it increase and then it decrease again when a is less than 0 or negative. But if your a is positive, the graph will increase first and then decrease and then increase again. All right, so that is what we have there. So now that you know that, right, remember that the general formula is y is equals to ax cubed plus bx squared plus cx plus d. Okay, so now we need to know this cubic function, right? How do we sketch it, right? So to sketch a cubic function, you don't need a lot of things. You just need 3 things. Number 1, you need the y-intercept, right? You need the y-intercept. Number 2, you need the x-intercept, okay? And then number 3, you need the turning points, okay? You need the turning points, which are also called stationary points, okay? Which are also called stationary points. So now, let's have an example maybe so that we see how can we actually sketch our first cubic function. All right, so I'm gonna give you an example here that I have. It says that sketch the function. The function is f at x is equal to x cubed, right? X cubed minus x squared, right? And then minus 10x, right? And then minus 8. So this is the function that we are required to sketch, right? So how would we sketch it? Remember, we need the y-intercept, the x-intercept, the turning points, right? So we're gonna start with the y-intercept, right? How do we get the y-intercept on a graph? Do you still remember? Yes, we say let our x be equal to 0, meaning where we see x, we put what? We put 0. So we're gonna say f of 0 is equal to 0 cubed minus 0 squared minus 10 into what? Into 0 and then minus 8. So the answer here that you get is negative 8. So your f of 0 is 8. If you can remember from our videos on graphical application, you can remember that this means when x is 0, right? This means when x is 0, your y is negative 8. Okay, when x is 0, y is negative 8 there. All right, so we got our y-intercept. Now the second thing to get, right, is the what? Is the x-intercept, right? Is to get the x-intercept. Now this one is a bit of a lot of work. Okay, for your work, x-intercepts, you're gonna let y equal to 0, meaning where you see y, you put 0. Remember, all of this here is your y, isn't it? So we put 0 is equal to x cubed minus x squared minus 10x minus 8. Now this one is gonna be a bit tricky, okay? Because remember, we are used to solving problems such as maybe x squared, maybe minus 10, maybe plus 10x, and then minus 6. This was a straightforward thing whereby you know that you just use the quadratic formula to solve for x. If this was equal to 0, you just use the quadratic formula. However, for this one here, which is a cubic function, we don't solve it like that, especially if it is in this form. We don't solve it like that, okay? So if it is full like this, if it is in this form whereby it has all the terms, to get the x-intercept, we're gonna use what we call I'm gonna show you what we call the synthetic method, right? The synthetic method to get those x-intercepts, okay? To get the x-intercepts, we're gonna use the synthetic method. So how do we apply that synthetic method, right? Let's first of all understand one thing. Understand that x-intercepts are x values that are gonna give us y as 0. They are x values that at those x values y is 0. Okay, so now this is what I first do when I want to apply the synthetic method. I'm gonna make a table, okay? I'm gonna make a table here, and then on my table I'm gonna say I have x and then I have y, okay? Then I close my table. Then I'm gonna write -3, then I say -2, then I say -1, I say 0, I say 1, I say 2, and then I say 3. This is the table that I'm gonna make, okay? I just said -3 to 3. I do that all the time. Creatures, I do that all the time, okay? So it's just a personal preference to start from -3 to 3. So now how do we get the y values, right? Remember, to get the y values, you will be substituting these x values into the equation. Here is our equation here, isn't it? That is the equation for f. So what you would be doing is that you start with -3. You say f of -3 would be -3 cubed minus into -3 all squared minus 10 into -3 and then minus 8. I'm just putting -3 wherever I see x. So the answer to this would be -14. Okay, it would be -14. So I put it here, -14. Then I do a similar thing, but now this time what I will be doing is that I'm gonna substitute -2. So we're gonna remove this -3 here and then start substituting -2. Okay, so start substituting -2. So I'm gonna put 2 here, 2 there, 2 there, 2 there. So if I put -2 there right into my calculator real quick, right, what I will have there would be 0. Okay, the answer is 0. Then I put it here. All right. Okay, good people, there's no need to continue. Once you get y as 0, that is the x that we were looking for. There's no need to continue. But if you still have not gotten 0, try all of them until 3 there. You must get one that is gonna give you 0. Okay, so now that we have that x value that gives us y as 0, that is exactly what we needed. Okay, now we're gonna do this afterwards. Now you're gonna draw for me, you know, ladies wear heels, right? You know, ladies who like to wear those heels, isn't it? Now that is what we are going to draw here, something similar to this. So you're gonna draw this table like this. Okay, you're gonna draw the table like this and then like this. Okay, let's try to draw it nicely like this, right? And then like this, right? And then here you're gonna put a bit of a box there, right? you put a box like this. Okay, you put a box there. So now after you have done that, please put 0 into that box. Okay, put 0 into that box. If you get your answer as 0, then you know that you did the right thing. So this is what you do, good people. Remember, we found our x value to be -2, right? I need you to write -2 here. You write x is equal to -2 here. All right, then now after you are done doing that, it's just above the box, you see that. After you are done doing that, this is what you do, good people. You go to this equation here, this one. Okay, you look at it properly. Now this is what you're gonna do. One by one, you're gonna drop those coefficients or write them here. Okay, so what is the coefficient here? It's 1, isn't it? You write 1. Then you say, what is the coefficient here? It's -1, so you write -1. Give them space, ne? Then you say, what is the coefficient here? It's -10. Okay, so you write -10. Then here, what do we have? We have -8, so you write -8. So basically, you are just taking the numbers in front of x squared and x cubed, then you take the last number, you all put them here. After you are done doing that, good people, this one you drop it down all the time. The first one you drop it down, then you write the answer here. 1, you drop it down as it is. Then please listen to this procedure, good people. You're gonna say, what is 1 multiplied by -2? Did you get that? You're gonna say 1 multiplied by -2. What is the answer? 1 multiplied by -2 is -2. Okay, then I need you to put a plus sign here, good people, and say, what is -1 plus -2? So meaning, what is -1 plus -2? Put this in your calculator. You must get the answer is -3. Then you say, what is -3 multiplied by -2? -3 times -2 is 6. Then you're gonna say, what is -10 plus, right? There's a plus, right? Plus 6. So -10 plus 6, that will be -4. Then after that, we say, what is -4 times -2? That will be +8, right? Then you say, what is -8, right, plus +8? The answer is what? 0. If you get 0 here, then you know that you did everything correctly. All right, so now that you have that, good people, even if, remember, if you didn't get me, you can just rewind the video and listen to that properly again. All right, so now that you have that, you have this is what you do, good people. You are gonna draw for me a big bracket, then you're gonna draw a small bracket, and then you equate to 0. Okay, after you are done doing that, this is what you're going to say. You are going to take this, you drop it down there. In fact, this is what you're gonna do. Remember that you have ax squared plus bx plus c, isn't it? That is what you're gonna write in here. You're gonna write ax squared plus bx and then plus c. Okay, so but literally you're not gonna write a and b and c. This is what you will do. Okay, you leave x squared, you leave x, then everything you take it out. Then you then say, here I have 1, right? You drop it down here, you write it here. Then here I have -3, right? You drop it down here, you write it with its sign. Here I have -4, right? You drop it down here, you write -4. Then here I have x is equals to -2, right? You go down here, you write x. If it was -2 here, you're gonna change it as +2, meaning you just take this -2 to the left, it will be positive, meaning we just change the sign here. If here we had x as 3, inside here we would write x -3. I hope that is clear. So now that you have this, you can easily simplify it, isn't it? Now you can say I have x squared minus 3x minus 4, right? And then you say x plus 2 is equal to 0. Alright, now that you will have a situation like this, good people, you must remember that you take this bracket as if it's your A, you take this bracket as if it's your what? Your B. Remember, AB will be equal to 0 if A is 0, because it will be 0 times B, and then it will be 0, or if B is 0. So this is what we're gonna say here. We take this as our A, this is our B. So we're gonna say x squared minus 3x minus 4 will be equal to 0, or x plus 2, the second bracket, will be equal to 0. So now here you can just use the quadratic formula and get your x values. I'm just gonna factorize it, right? So I'm gonna say I have x, and then I have x, then I have 4, then I have 1. I'm gonna have negative 4 plus 1, so that it gives me negative 3. Or we have x plus 2, which is equal to 0. Then I continue simplifying, right? I know that this is now the same as saying A times B, right, is equal to 0, just like this here. So I'm gonna say x plus 1 will be 0, or x minus 4 would be 0, or our x plus 2 would be 0. Then I solve it once. Then I say, therefore, x will be negative 1, or x will be 4, or my x would be negative 2. And as coordinates, you can write them as negative 1 and 0, and then you can say 4 and 0, and then you can say negative 2 and 0 there. All right, so now these, remember, good people, what did we find here? These are our x-intercepts. Okay, those are our x-intercepts. So you can definitely see that to find x-intercepts, it's a bit of a long journey. Okay, we have to use the synthetic division. Remember, what do? We draw a table, we put x to 3, we keep on substituting these x values into the equation until we get a y value that is 0. Then once we get that y value, that x value, we write it here. Then we draw our heel here, we say 0. Then after that, we're gonna drop these coefficients like this, or rather we're gonna write them here. And then after that, we drop 1, it multiplies that, then you write it, then you add this and that, you do the same thing, you do the same thing. If you get 0, you know you did correct. Then after that, these 3 numbers, you're gonna drop them and say, this is your A, this is your B, that is your C. That is why they come here. Then you can just equate to 0. Remember, here you wanna change the sign. Then you equate to 0, you get this x-intercept. What was the y-intercept? We know that the y-intercept is 0 and negative 8. Now remember, to sketch this graph, the last thing that we need is what? Is the turning point, okay? The last thing that we need is the turning point. So how do we get the turning point of this graph? Well, to get the turning point, this is what you do. You find the derivative, okay, of your graph. Then after that, you equate that derivative to 0. Okay, you equate it to 0, then you solve for x. Once you solve for x, you're gonna get 2 x coordinates, or 2 x values. Those 2 x values will be at 2 points. Those 2 points are your turning points. Okay, so what is the equation of f, right? Remember, the equation of f is, let's look at it here, x squared minus 10x minus 8, right? Can you try to find the derivative there, right? So to get the derivative, you would say, since our f at x, right, it's equal to it's equal to x cubed, right? X cubed minus x squared, and then you have minus 10x, and then you have minus 8, right? To find the derivative of f, right, it would be, remember, 3x squared, right? And then it will be minus 2x, and then minus 10. By now you should know how to apply the rules, right? So this will be the derivative of f. Now, what is a derivative? It's an equation that helps us to find the gradient at any point. All right, so now why are we going to set our derivative equal to 0? This is what you must know. At turning points, if this is my turning point here, and then I put a tangent at those turning points, the tangent will be looking like this, another tangent would be looking like this. All of these tangents, can you see that they are horizontal? So if a tangent line is horizontal, it means the gradient of that tangent would be 0. Okay, the gradient of that tangent would be what? 0. But if a tangent maybe is slanting like this, then you do know that here your tangent is increasing, or the gradient is increasing. Okay, what about here? If I were to put a tangent here, the tangent line will be decreasing. So the only points whereby the tangent line is equal to, it has a gradient of 0, is on the turning points, which are your stationary points. So that is why here I'm gonna equate this to what? To 0, because by equating it to 0, I'm gonna be solving for x coordinates where the gradient of the tangent is 0. Right, remember the derivative is the gradient of the tangent to the graph. So where is the gradient of the tangent 0? At which x values? So I then say, okay, we can use quadratic formula here. So I'm just gonna quickly factorize it and then say I think I'm gonna have 3x and then x. Then what else are we gonna have? 2 and 5. That will be 6 and no, we can say, what gives us 10? It's 2 and 5. Okay, this one has no factors, so it's probably best to use the quadratic formula. So if you can apply your quadratic formula, you'll find that x is equal to negative 1.52, or your x is equal to 2.19. Okay, so you have two x coordinates. Why do we have two x coordinates? It's because our turning points, right, this is the first turning point, maybe the x value will be negative 1.52, right, and then we wouldn't know the y value. Here also it would then be 2.19, and then we won't know the y value, but we do know that those are the x coordinates at the turning points. So what do we need? We need to find the corresponding y values. How do we get the corresponding y values? Remember, if you know x values, you can get y values by substituting into the original equation. Right? So you can then say, therefore, for this one, for negative 1.52, the y value would be what? Where you see x, you put negative 1.52. So you say negative 1.52 cubed minus negative 1.52 squared minus 10 into negative 1.52, then you say minus 8. The answer there would be how much? It would be 1.38. So it means here it will be 1.38 there. Then you substitute for here, right? You then say, what about for this one? F of 2.19, the y value would be what? It would be 2.19 cubed minus 2.19 squared minus 10 into 2.19 and then minus 8. Then what would be the answer here, right? The answer would be negative 24.19. Okay, so here it means in this bracket here we would have negative 24.19, then you close the brackets. Okay, so that is what you would have there as your turning points. Those are your two turning points. Now, good people, what is left is just to sketch this graph. Okay, so how do we sketch this graph using all these coordinates that we found, right? This is what I'm gonna do. I'm gonna make a list of all the coordinates that we found, okay? Just give me a second. Great. So good people, this is what this is your y-intercept. You saw how we solved it, right? By letting x equal to 0. This is the x-intercept. How did we solve it? By using the synthetic method. And then this is a turning point. How did we get the turning point? We found the derivative, then we equated the derivative to 0, then got the x-intercept of the turning point, then got the corresponding y values of the turning points. Alright, so now to sketch this graph is very, very easy, good people. I don't want to lie to you, it's very, very easy if you can just listen to what I tell you. So let's remember that the equation was, remember, grx is equal to it's what? It's x cubed, right, minus x squared, and then minus 10x, and then minus 8. So to sketch that graph, this is what you do. First of all, you check the value of a. Is your a positive or negative? Yes, your a is positive. So you know that the shape will be like this. It increases first, decrease, and then it increases again. Okay, so that is what you are going to write. Okay, without the Cartesian plane, this is what you do, good people. With a nice free hand, you draw this. With a nice free hand. After you are done doing that, good people, you now just say, you just now put the coordinates. Oh my goodness, this thing is so easy. You now just put the coordinates. What is the coordinates of the turning points, right? This is the first coordinate, that is the second coordinate. Now the question is, which one belongs to which? Good people, this is the trick. This is the left side, right? This is the right side. We always move from left to right. The smaller x value is the one that always is on the left. Between negative 0.152 and 2.19, which one is bigger or which one is smaller? This is smaller. So it means here I'm just gonna write negative 1.52 is to 1.38. Okay, and then the one that is bigger, I just write it here. I say 2.19 is to negative 24.19. You see, as easy as that, good people. After that, now you need to put your y-intercepts. So here you need to be careful in terms of your y-intercepts, okay? This is what I do all the time. How many x-intercepts do I have? We have 1, 2, 3. Good people, since we have 3 x-intercepts, it means we have to have a line that cuts the graph 3 times. This is the line here. It's gonna cut the graph at 1, 2, 3. Okay, it cuts the graph at what? At 3 points. Okay, so you're gonna have this one here, this one there, this one there, and then that is it. So we call this axis our x-axis. Alright, we call that the x-axis. Since our x-axis is cutting the graph at 3 points, those 3 points would be our x-intercepts. Now, how do I know which coordinate is for this one, for that one, for that one? Easy, good people. You just focus on the x-axis. You just focus on the x values, okay? You're gonna arrange them in order. How would you arrange these things in order? Which one is the smallest number between -1, 4, and -2? Yes, it's -2. So it means here, right, here you would write this one as -2 and 0. Okay, then this one here, the second one is -1. Here you just write -1 and 0. Then this one you just write what? You just write 4 and 0. Okay, nice. My line is cutting the graph at 3 points because I have 3 x-intercepts. Now, good people, now you have your 3 x-intercepts. The last thing is to sketch the y-intercept. Okay, so this is the one that becomes a bit tricky, but it's not difficult, good people. Just focus on the x. Just focus on the what? On the x. 0 is where can we place 0 here? Is it between -2 and -1.5? Or is it between -1.5 and -1? Or is it between -1 and 2? Or between 2 and 4? Yes, it should be between -1 and 2. So you just throw it anywhere between -1 and 2. But in that case, since it's the y-intercept, we're gonna have our y-axis. So you're gonna have something like this. This is your y-axis, okay? So that y-axis, you now write it like this. So you just do this, and then you do that, and then you write y there. So that's your y-axis. So do you see that when I talk about x-intercepts, I'm talking about the x-axis. When I talk about the y-intercept, I'm talking about the y-axis. Now, at that y-axis, at this point here now, that is your y-intercept, okay? Where your y-axis cuts the graph, that is your y-axis, your y-intercept. So you just write 0 and -8. That's your point there. Then good people, here you just write 0, because remember, where your x-intercept and your y-intercept, no, where your x-axis and your y-axis meet, the point is always 0. Then you are done. Then you are completely done. That is your graph of GRX, good people. I always enjoy sketching cubic functions, and this is the reason why, because they are so easy. Okay, they are very, very easy, good people. But just follow what I tell you, okay? You just have to, you don't draw, you don't do it like you're drawing a parabola. Like, you don't draw this and then now you start sketching. No. All you do is that check the value of y. Is the value of a, is your a positive or negative? If it's positive, you know the shape is like this. Now start drawing that shape. Then after drawing the shape, what do? You start here by saying, on the turning points, you start giving the turning points by focusing on x. Just look at the one that is smaller, it will be on the left. The one that is bigger will be on the right. Then go to your x-intercepts. You count how many are they. 1, 2, 3. So it means I must have a line that cut the graph at 3 points. Then we just give each point the correct coordinate, the correct point there, by just arranging your x-axis in your x values in order. You start with the one that is smaller, then go with the one that follows that, and then the one that is bigger on the right. Then after that, you go to the y-intercept. By focusing on the x, you know that 0 should be between -1 and 2. Just focus on the x. It should be between -1 and 2. So that's why I'm just gonna draw a straight line cutting the graph at that. So that would be my y-intercept, and then I just write 0. Then I'm done. Okay, so we're gonna sketch more on the next video, right? It's so much fun, good people. Stay tuned, right?